Now let's try this problem of 41 of your textbook. This problem says that a uniform ladder of length 10 meter. I've already shown a diagram. This is a ladder. This is the ground ladder of 10 meter and mass 16 kg. That means, well, this ladder is 10 meter ladder. So from here to here, the length is 10 meter. 10 meter. And its mass is 16 kg. So here there is a 16 kg mass. 16 kg mass. And of course, 16 kg works at the center. So from here to here, it is 5 meter. And it rests against a wall of which is 37 degree. So this is 37 degree. The vertical wall is frictionless. So mu here in the vertical wall is 0. And the ground is rough. Of course, the ground has to be rough because if both are frictionless, then the ladder cannot rest. Ladder will simply freeze down. There is some friction here. Mu is equal to, say, mu. We do not know what is the value of mu. An electrician of weighing 60 kg climbs up the ladder and he stays on the ladder at a point of 8 meter from the lower end. That means somewhere here an electrician is standing and his weight is 60 kg. 60 kg. This is 16 kg. And the electrician is 8 meter above the ladder. Electrician is 8 meter above the ladder. What will be the normal force and the force of friction on the ladder by the ground? That is, they want to know. What will be the normal force and the force of friction, that means on the ground, and what should be the minimum coefficient of friction for the electrician to work safely? That is a question. Now, look at this particular ladder. It will be better if we take a free body diagram of the ladder separately for you. It will be easier to understand. This is the free body diagram of the ladder. And what are the forces acting on the ladder? This vertical wall will apply a normal force in this direction. Let us say this force is N1. And this is 37 degree, we know. Right here, there is a force here. There is a force here, which is 16 kg. Right? Which is 16 kg, which is 16 kg, we should call it 16g. There is another force here. It is 60g. And at this ground, we consider this point for the sake of our arithmetic. Consider this point as P. At this ground, there is a vertical normal force. Let's say this force is N2. And also, there will be a frictional force. There will be a frictional force. There will be a frictional force F. Now to start with, this, if you look at the free body diagram of this ladder, there are vertical forces N2 and vertically upward is N2, downward is 16G and 60G. And there are horizontal forces of N1 and horizontal forces F is equal to mu N2. Mu N2. They have to balance. Further, if you consider the rotational effect of this on this ladder, this N1 creates an anti-clockwise rotation, considering P as the pivot, and 16G creates a clockwise rotation, 60G has to create a clockwise rotation. They have to balance each other. But the force N2 and F, which passes through the pivot P, does not contribute in the rotation. So let me tell you, whenever you have to solve this kind of a problem, you can consider the pivot anywhere. If you consider the pivot anywhere, the result will be same after doing the arithmetic. But you should choose the pivot in such a way so that it is convenient for you to work with. Now, since I have taken the P as the pivot, then in the rotational motion, the effect of F and N2 is cancelled because both of them passes through the point of P, which is the pivot. Now let us solve or equate these forces one by one. N2 here, N2 is a horizontal force towards left. N2 is the horizontal force. N2 is the vertical force upward, and downward forces are 16G plus 60G is equal to 76G. If you put the value of G, this becomes 745 Newton. This is one relation. We have found the value of N2. Also, we have another relation. If you take the horizontal forces, N1 working towards left has to be mu N2 working towards right. Also, we write N1 is equal to mu N2. Let's say this is relation 2. So we have taken horizontal and vertical forces. Now we consider the torques. Now we go to consider the torques. Consider torques on the ladder. If you consider torques on the ladder, then N1 is a force N1 which produces a counterclockwise torque. Torque on the ladder, let me also clarify, torque on the ladder around around P. This point P, of course, I have said it is arbitrarily taken. You can take it around P, Q, M, whatever it is, the result will be finally same. So, what is the value of torque of N1? N1 multiplied by this perpendicular distance of N1 line of action of the force N1 from P. This perpendicular distance is, if you measure this perpendicular distance, the ladder is 10 meter high and this is 37 degree. So this is 10 cos 37. 10 cos 37. So it is N1 multiplied by 10 cos 37 degree. N1 is the only anti-clockwise torque, and 16G and 60G are clockwise torques. Now, N1 equal to 16, N1 will be equal to, so will be counteracted by 16G is the force into the 16G, this distance is 5 sin 37 degree. 16G into 5 sin 37 degree plus 60G, this is 8 sin 37 degree. This distance is 8 sin 37 degree. So this is the equation of two balanced torques, right? Now, if we solve this equation, simplify this, cos 37, we know that cos 37 is 0.8. So 10 cos 37 is 8. So this is 8 N1 is equal to sin 37 is 0.6. So 0.6 multiplied by 5 is your 6 by multiplied 0.6 multiplied by 3 multiplied by 16, that is 48G. 48G plus, again sin 37 is 0.6 multiplied by 8 is 0.48. If you do it, it will become it will become 16 into 8 into sin 37. This will become 288G. 288G. This is equal to 336G. So 8N1 is 336G. Therefore, what is N1? N1 is equal to 336 divided by 8. So it is 4 and 2. It is 42G. 42G is equal to approximately 412 Newton. So we have got a value of N1, 412 Newton. So first question asked was, what should be the minimum coefficient of friction that we shall find out later. First is what will be the normal force and the force of friction on the ladder. Normal force on the friction is, first we have already found N2. This is result 1, 745 Newton. Normal force on the Newton. And frictional force we shall find out, because N1 we have found is the 412 Newton. If that is so, then N1 we have got. So what is N2 we have got, N1 we got. So therefore mu is equal to, from this equation 2, mu is equal to N1 by N2, N1 by N2, N1 by N2, N1 is 412, N2 is 745, N1 by N2, mu becomes 0.533. This is the value of mu. So we know the value of the frictional coefficient mu, which is required. Now, in this same go, we shall also take the next problem, because next problem is only a tail end of this problem. So we shall take the next problem together. What this next problem say? Suppose the frictional coefficient between the ground and the ladder in problem 41 is 0.54. That means it is less than the required friction coefficient. Obviously, if the frictional coefficient is less than the required value, the ladder will start slipping down. So in order to stop the ladder slipping down, things can be done. One is, we can tell the electrician, do not go so high up. So you don't go up by 8 meters. You remain a little lower and do your work. Or we can say, what we can do, we replace the electrician by a thinner person who is not 60 kg, maybe who is 40 kg. So here the question is, find the maximum weight of an mechanic who could go up and do the same work at the same position. That means the electrician has to anyway go up to 8 meters. But a 60 kg man cannot go up to 8 meters if the frictional coefficient is low. So a thinner man has to go. We have to find out how thin that man should be. If we have to do this, we have to only retrace the same equations. We retrace the same equations. What do we find? N1 equal to mu N2 we have already found. So now, here, N1 equal to mu N2, this relation is known. Now mu is given 0.54. So, N1 is equal to 0.54 N2. N1 equal to 0.54 N2. And similarly, considering the vertical forces on the ladder, in equation 1 earlier, we have seen N2 equal to 16G plus 70G equal to 76G equal to 76G. But now, the weight of the person, mass of the person is no more 60, it is M. So considering this is one question, one point, we give a line here. separation line here. Then we considering the vertical forces. Considering the vertical forces, what we get? N2 is equal to N2 is equal to, now we get 16 plus M. 16 plus M G. Now 16 plus M, both have the G. 16 plus M G. Right? And once again, considering the torques, yeah, consider like before, considering the torques like before, considering the torques like before, what do you get? N1, 10 cos 37, 10 cos 37 equal to 16 G 5 sin 37 plus, now it is no more 60G, it is capital MG 8 sin 37 degree. From here we get, like this was N1, sorry, like earlier it is 8N1, 8N1 is equal to, earlier it was 48G, now also it remains 48G plus, earlier it was calculated 288, now you cannot calculate, now it is 8 into sine 37, sine 37 is 0.6, so 8 into 0.6 is 4.8, so 4.8 mg, 4.8 capital M, 4.8 capital Mg. So from here we go to the next step. From here we go to the next step. Left hand side was 8N1 and the value of N1 was already known, 0.54 N2. So 8 into 0.54 N2 will be equal to 48G plus 4.8 capital M, capital MG. So from here we get 8 multiplied by 0.54 is 4.32, 4.32 multiplied by N2 is equal to 48 G plus 4.8 capital M G. We have reached the equation. Let us say, let us give it a name equation. What name should we give? Let's say give it a name 3. Equation 3. Once we have done this, now here we have got 4.32 N2 is equal to such and such. Earlier we have got N2 equal to this, N2 equal to this. So let us give this equation 3, and let us call it equation 4. So from equation 3, from equation 3 we get, if we multiply both sides of equation 3 by 4.32, what do we get? 4.32 N2, 4.32 N2 is equal to 16 plus capital M G multiplied by 4.32 multiplied by 4.32. This is equal to 4.32 mg plus 16g multiplied by 4.32 is equal to 69.12 G. Let's say this is equation 5. Now look at this. Here we have got 4.32 N2 is equal to this. Here we have got 4.32 N2 is equal to this. So both right hand sides are same. So we can clearly write, therefore, so 48 G plus 4.8 mg is equal to 4.32 capital Mg plus 69.12 G. All these G's gets cancelled. So what we are left with, we have M here and M here. So what we are left with is 4.8 minus 4.32 into capital M is equal to 69.12 minus 48. Because all these G's gets cancelled. 69.12 minus 48. And therefore, so this is equal to 4.8 minus 4.32 is 0.48. 0.48 capital M is equal to 21.12. From here, you can find out M is equal to 44 units kg. So, what we found really, let's revise this whole thing. In this ladder, the necessary coefficient of friction is 0.533. But the coefficient of friction is less and equal to 0.54, then the man who is going up by 8 meter on the ladder can have mass only up to 44 kg. If the man is stronger or heavier than 44 kg, the ladder will simply slip down and crash on the ground.